Good afternoon to everyone. In this lecture, we will learn about the domain relational calculus. Domain relational calculus uses domain variables that take on values from an attributes domain rather than values from an entire tuple. So in a relation, we have tuple. So this tuple represents the entire record. Each record consists of several attributes, and so in domain variables what we use is the attributes, and these attributes are represented by domain variables. If there are 5 attributes, then we use 5 variables which are definitely user defined. The names of the variables is user defined, and for each of the attribute we use some variable which is called as domain variable. Now let us come to the formal definition of the domain relational calculus. So whenever we write some domain relational calculus expression, then this expression consists of this form, where we write the name of the domain variables x1, x2, xn. So these are the variables that we will be outputting, and then a pipe, and then the predicate, and this predicate is definitely based on the various attributes in our relation, and definitely x1 to xn represent all the attributes, and x1, x2 are the domain variables which are used for different attributes. Now this predicate can take several forms, and the first form of this predicate is that we can write that these domain variables are in the relation R. The second is that we can write an expression such as x some operator y. So where x and y are two different domain variables, and this operator can take any of these forms. Then the third form of this predicate could be x operator c. So this predicate p may consist of some domain variable x and some constant term c, and we can use any of the operator out of these to write atom of this form. So what is an atom? An atom is a smaller part of this predicate, and this atom is definitely consists of some formula, and this formula is definitely based on 3 different rules which we have recently studied. So definitely the following rules are used for writing the formulas in the predicate part. So the first is that an atom is a formula. So some formula we will be using in the predicate part, and each formula is called as an atom. So if P1 is a formula, then so are not P1. So not P1 is also one formula. And if P1 and P2 are two different formulas, because the predicate may consist of different formulae, then we can use OR operator, we can use AND operator, and we can also use implies operator for the two different predicate part formulas. Then if P1x is a formula in x, where x is a free domain variable. So what is a free domain variable? A free domain variable is a variable where we do not have any restriction. So here if I write P1x, so x here is not attached with some quantifier. So x is a free variable. So if x is a free domain variable, then in domain relational calculus we can also write expression like for there exists some x in P1x and for all x in P1x. So this is also these are also two different formulas which can also be written. Then if we use the existential qualifier with the 3 different domain variables, then we can use this existential qualifier symbol with each of the domain variable, or we can use one single existential qualifier, and then separate all the domain variables with commas, then it is also the correct form. So this was all about the definition of domain relational calculus. We will see some of the examples of the domain relational calculus in part 2 and part 3 of this series lecture. So thank you for watching.